All right, here we're being asked to compute the integral from negative infinity to 0 of x times e to the negative 2x. All right, there's a few things that should catch our eye right off the bat. First of all, this is an improper integral. The way that I know that is this goes from an infinity up to 0, negative infinity up to 0. And anytime you have an infinitely long interval that you're integrating over, it's going to be an improper integral because it doesn't satisfy the criteria of the fundamental theorem of calculus that says you have to be on a closed finite interval in order to use the fundamental theorem of calculus. So we have to handle this guy. Now, fortunately, I know how to handle that. You'll recall the way that we get around this idea of going from negative infinity up to 0 is we just don't. We go from, we'll pick a letter. Usually a lot of textbooks will use the letter B. It doesn't have to be a B. It could be K, C, Z, whatever. But this is now a finite interval, and then I'll do the integration. And when I'm finished, when I'm done with the integration, then I'll take the limit as b pushes its way on out to negative infinity after we're done. So it's kind of a nice little backdoor way of getting around the fundamental theorem of calculus. But I also see a second issue. In actually computing this integral, this is going to be kind of tough because u substitution unfortunately doesn't work. There's a product which isn't the nicest thing to handle. There's just no real straightforward integration technique that'll handle x times e to the negative 2x. But then I noticed because it's a product, this might be a good time to use integration by parts. You remember studying integration by parts some time ago, and so this is where you pick a u and a dv and you do integration by parts. So in fact, that's why I chose this example to work with you. I just wanted to show you that you can do an example, or you can do problems where you have an improper integral, which is its own issue, as well as integration by parts or other types of issues, and they can be handled together if done correctly. Okay, so primarily I think this is an integration by parts problem, as well as being an improper integral. Okay, so we'll do the integration and then we'll deal with the limits when the time comes. So the integration by parts is kind of the main thing in our face right at the moment. So for integration by parts, I think we know the drill. We need to pick a u and a dv, and then based off of our choice, then we'll find the du, and we'll retrieve the v as well when we're done. Okay, so now I'm going to assume that you guys already know integration by parts. We studied it some time ago. If what I'm about to say sounds completely foreign, just go find some of our integration by parts videos and brush up on that first. All right, I'm going to assume that you guys all will know that the u should be x and the dv should be e to the negative 2x. And again, that's something we talk about as well. How do you make a decision on who's chosen to be the u and who's chosen to be the dv? But anyways, once we made this decision, then that would automatically make the du equal to 1 because that's the derivative of x. And then the v would be negative 1/2 e to the negative 2x, and I got that by integrating e to the negative 2x, which I didn't really write a lot of details, but that would be its own little mini u substitution problem in just integrating this guy. But you can do that in the margins of your notes or whatnot. Okay, all right, so here we go. I think we remember integration by parts. It says that the integral of u dv is equal to u times v minus the integral of v du. Okay, now you might be a little concerned because you might say, well, Devin, this is for kind of an indefinite integral, but here we have limits. What do we do with the limits? Well, if you have limits, it's not a huge deal. Basically, all we do is if you have limits here, then for this first term here, we'll be evaluating that from blank to blank. And then this second integral here is also from blank to blank. So basically, in effect, I would say do the entire integration by parts, do the entire thing, and then when you're done, put your brackets and go from blank to blank or what have you. But just do all your integration first, right? And we'll do the same here. All right, so let's get rid of that. Some of that extra stuff. There we go. Okay, so let's do it. Let's do it. So here we go. In white, this guy's integral will be the limit. Hope I have space for all this. As b goes to negative infinity of u times v. So negative 1/2. I'll squeeze in the x. Negative 1/2 x e to the minus 2x. And then again, this is evaluated from b to 0. All right, minus the integral of v du. I'll pull the negative 1/2 out since it's a constant. That will make it plus 1/2. The integral from b to 0 of e to the minus 2x dx. Okay, so this will be the limit as b goes to negative infinity. It doesn't really matter to me if you want to go ahead and plug in these limits or wait until after we do the second integral. You know what? I guess we can go ahead and plug it in. I mean, it doesn't really matter, I suppose. If you plug in a 0, you'll get 0. If you plug in a b, you'll get negative 1/2 b e to the negative 2b. But since we're subtracting 0, plugging in 0 minus plugging in b, then the minus and this negative will actually make a plus 1/2. Plugging in b, we get b. E to the negative 2b. Okay, so that's good. So, okay, we just went ahead and plugged those in right now. We could have waited. We could have waited until we did this integral, but, whatever. I think that's okay. All right, and then let's see. Let's do this integral here. What is the integral of e to the negative 2x? Well, I'll tell you what, just so I don't mess up my work as I'm doing it right now, let me just do it over here on the side. Integral of e to the negative 2x would be negative 1/2 e to the negative 2x. So let me just take that and copy and paste it right now. I'll just go ahead and do that right this moment. Negative 1/2 times a half would make negative 1/4 e to the negative 2x, bracket from b to 0. And so we're only going to plug 0 and b just into this last expression. We already plugged in 0 and b into this first expression here. All right, let me get rid of this. Okay, integration by parts is basically done, so I'm going to get rid of this as well. Okay, make a little bit more space. Okay, so let's see here. What's this going to be? We'll have the limit as b goes to negative infinity of 1/2 b e to the negative 2b. All right, and then minus. All right, let's see if we can do this carefully here. Plug in 0 and plug in b and subtract. So if you plug in 0, e to the 0 is 1. So we have, let's see here, minus 1/4, right? Minus 1/4. Okay. All right, and then we'll have minus, but then this negative will make this a plus 1/4 e to the negative 2b, right? Because we're going to plug in b that time. So if you need to replay that part of the video or maybe do it by hand just to double check your algebra and what have you, then I think that would be a wise thing, to do. All right, so anyway, let's see what we get here. Let's see what we get. Now, if we were to let b run on its way to negative infinity, then you would have basically 1/2 times something going to negative infinity would lead that portion to negative infinity, times e to the negative infinity would turn that to a positive. So this giant thing right here would be going to negative infinity for sure, right? And then we'd have minus 1/4, which isn't really going to do anything. And then here we would have 1/4 e to, all right, so this expression would be going to infinity. Now the tough thing about this one is negative infinity plus infinity is still an indeterminate form. So what we have to do if you have an unfortunate situation like this is to see if there's some sort of algebra that you can do on this limit to kind of help make it more clear. Is one of these growing faster than another? I will say that negative infinity plus infinity doesn't equal 0, because it also somewhat depends on how fast they're going to 0 and some other things like that. So don't automatically think that these cancel or anything like that. All right, now here is one thing that I see. Unfortunately, I'm kind of running out of space. Actually, I'll tell you what I'll do. I'll just actually erase this up here, just so I don't have to flip to the next card or whatnot. Okay, so I'm going from here up to here. I'll change colors just to make it clear what's new stuff and what's old stuff, that sort of thing. I actually have the same factor here and here. And this minus 1/4, when you're talking about infinities, subtracting a fourth isn't really going to do a lot. You can basically consider it to be negligible and take it out, but I'll keep it in there just so that nobody has a question about it. But basically, you would have something like this. The way I would formally write this is I would say this right here, bringing this up here, we get equals the limit as b approaches negative infinity of, I'm gonna pull out these e to the negative 2b's out front. Okay, e to the negative 2b times the quantity, right? Times the quantity 1/2 b, right? 1/2 b from this term, plus 1/4, that's from this term. Okay, and then minus 1/4, because this term did not have this term right here did not have an exponential term in it. So I think this would make it much more clear how all this stuff is going to work. So now let's try that limit again and see if it makes more sense. So now we have the limit as b goes to negative infinity, e to the negative 2b. If b is negative, then negative makes a positive. E going to a very, very high power will go to infinity. This part right here, as b goes to a negative infinity, you take half of it, that's not going to slow it down. It's still going to negative infinity. You add a fourth, it's still going to negative infinity. So this will be negative infinity. And then you have this piddly little minus a fourth. Okay, again, this is negligible. That's a drop in the bucket. Infinity times negative infinity is safe to say that this goes to negative infinity right here. So what does that mean? Like what's an answer of negative infinity mean? That means that we have accumulated an infinite amount of area, in this case below the x-axis, for this particular integrand here, x times e to the negative 2x, which you'll notice on the interval negative infinity does stay below the x-axis because x is negative and e to the x is positive. And so it's interesting to note. But this basically says we've accumulated an infinite amount of area on this interval. And so what do we say when we have an improper integral that goes to negative infinity or accumulates that much area? We say that this integral right here, I'll write it in pink right here, this integral right here diverges. That's the word you're looking for, diverges. Now, you will do plenty of examples where you do all this math, you might do integration by parts, whatever, and then you take the limit, and you get a nice round answer like 2, right, or 7, or a half, or something like that. And if you get an answer, like a finite answer, then you would say that this integral converges. But in this case, it diverges because the area or the integral here wound up being infinity, or in fact negative infinity. So these limits can be kind of tough. These integrals can be kind of tough. And the only way to get better at them is to practice. So hopefully this example kind of opens your eyes a little bit to some of the different things you can expect to see in regards to integration by parts, as well as improper integrals.